So, picking it back up again with the operating system. An operating system can be a single tasking system, or it can be multitasking. So a single tasking operating system, it's only going to run one program at a time. And multitasking programs, which are much more common now in OSs, it allows the user to perform more than one computer task. Such as the operation of some application that you're working on, right, at a time. You can do more than one at a time. So the operating system is able to keep track of where you are at in these tasks and go from one to the other without losing the information. Now, there's a small caveat to that, and that's that the foreground is a term that means the application that the user, or you or me, is working on. And the background are the applications that are behind the scenes, such as certain operating system functions or other applications you've opened but aren't using right now, right? Now, also, the OS manages other processes during this. Now, a couple other terms to differentiate. Users. So I just talked about tasking, right? Single tasking and multitasking. Now I'm talking about single user and multi-user. So some OSs support a single user, right? So a single user OS is an operating system that supports only that one user at a time. So DOS is an operating system. Windows 3X, Windows 95, Windows 97, Windows 98. They're all single user OSs. Now some OSs, most of them nowadays, are multi-user capable. A multi-user operating system is a computer system that's going to allow multiple users that are on different computers to access a single system's operating system. All the resources can be accessed simultaneously. And that's kind of shown on this figure on the slide, right? So users on the system are connected through a network. And networks, servers and supercomputers, etc., these allow hundreds to thousands of users to connect at the same time. Thus, they are multi-user OSs. Now, memory management is a form of resource management that's applied to computer memory. The essential requirement of memory management is to provide ways to dynamically allocate portions of the memory to programs at their request and free it up for reuse when it is no longer needed. So RAM consists of chips, as we've discussed, on the motherboard, and it holds items such as data and instructions for the processor, the CPU, to interpret and execute. We've had that conversation before. The OS allocates and assigns data and instructions to an area of that memory. And then finally, the OS is going to release these items from memory when they are no longer required. So then there's this thing called virtual memory. Now, virtual memory, it's going to combine your RAM memory, right, your random access memory, with temporary space on your hard disk. So if your computer lacks all the RAM it needs to run a program or an operation, Windows, for example, is going to use virtual memory to compensate for your lack of RAM. So the more RAM memory on your computer, the faster the program will generally be, because it doesn't have to go to this virtual memory to get more instructions. So the area of the hard drive used for virtual memory is called a swap file. And it's a swap file because it actually swaps or exchanges the data or info and instructions. A page is the amount of the data that actually gets swapped. And paging is swapping items between memory and storage, right? Now, sometimes you'll hear of the term thrashing. Thrashing is when an OS spends a lot of time paging instead of actually executing. So I will, the next slide shows you those in a picture. The picture is from the book. I just enhanced it with my words in blue. So first, start in the top left. You've got your physical memory, right? But jump down to the bottom right on the hard drive. That would be the virtual memory because it couldn't get all of it that it needed into RAM. So back to physical memory where the RAM is, right? And so you can have these swap files go on, right? And again, there's this area of the hard drive that is used for virtual memory, and this is called a swap file because it swaps or exchanges the data, the info and instructions going back and forth because it couldn't get everything in there. And as a review, paging is that swapping of the items between memory and storage, the physical memory and the virtual memory, right? And thrashing is when the OS is going to spend a lot of time going back and forth. So just wanted to make those jump out at you a little bit. Now, the operating system determines the order in which tasks are processed, right? A task or a job is an operation that the processor is going to manage. So a buffer is a segment of the memory or storage in which items are placed while waiting to be transferred from an input device to an output device, right? In computing, we also refer to spooling. Spooling is a specialized form of multi-programming for the purpose of copying data between different devices. So in modern systems, right, it's usually used for mediating between a computer application and a slow peripheral, like a printer, right? So we spool things to a printer, right, so that the computer can keep going. Now, a device driver, this is a piece of software that allows your computer, the operating system, to know what the peripheral is about, what the item is about. So it allows your computer's operating system to communicate with some hardware. So that's what the driver is written for. So if I plug in a mouse, the mouse has a driver, and now my OS understands the mouse, right? So generally, a driver communicates with the device through the computer bus, which is used to connect the device to the computer. So when you start up a computer or connect a device, the OS loads the device's drivers. And today, most devices and OSs support plug and play. We talked about that a few lessons back, which means that an OS automatically configures new devices for you. Bam, done. So specifically, it assists you in the device installation by loading the necessary drivers automatically. And now, then the driver is going to communicate with the device, with the OS for you. Okay. Now, operating system functions. OSs typically include a performance monitor, which is a program that assesses and reports information about the computer's devices. How is it doing? Kind of like a health check, right? So in today's complex, dynamic, networked environment, server administrators, they work really hard on a wide range of operating systems and the various requirements that go into them and solutions and fixes. So the operating system is based on software, has some software that manages the hardware and the software resources to help the administrator out. And the operating system has this monitoring system in it that is designed to provide these custom metrics across different OSs that are used and supported APIs that's going to allow this close integration with your OS. So the basic need of any server administrator while monitoring a network is this consolidated view of the different metrics. How is it functioning? Is it functioning within range? Like a car, you don't want to redline it too often or you're going to get in trouble. It's going to crash, right? So we don't want that. So this is, it's going to do its own monitoring, right? How's the CPU doing? Is it running at too high a rate? Is the RAM full based on what you have open? That sort of thing. It'll even provide some fault detection for us. So the OSs typically provide a means to create interconnect connections also. So if I have a cable or a DSL, that would be for a wired system, or I might use Wi-Fi for a wireless system. And the operating system is going to create that connection for you. So some OSs even include the browser and an email program. And this is going to enable us to begin using the web and communicating via the internet. Now, OSs also sometimes include a firewall, right? In fact, I would say today all major OSs have a kind of firewall installed in them. For Windows, it's called Windows, well, no, Defender is for antivirus. That's built in. It also has Windows Firewall, right? That's the Microsoft Windows application in the OS that notifies the users of suspicious activity. It's not a high-end firewall like you would have in a specialized high-value business, but it's still a firewall. Yeah, so OSs do have firewalls generally built into them. Now, most operating systems and software programs provide service packs, right? So one of the security risks is that there are vulnerabilities. And one of the productivity risks are there are things that need fixed, inputs, inefficiencies gained. And you can get those through service packs. Service packs are generally free of charge. And they can be done automatically or manually from the developer's website. Windows, Microsoft Windows OS, it enables automatic updates by default. So what's the difference between a patch and a service pack? Well, service pack rolls together all the patches, the hot fixes, the other type of patching. Hot fix is an urgent patch, right? And then there are other patching that goes on. A service pack is going to roll everything together over a given period of time, and where a patch is going to try and fix a specific problem, right? And a hot fix, hot fix is going to try and fix an urgent problem. So that's how we get the updates to make sure it's secure and to make sure that it's most efficient for us. Now, OSs often provide users with a variety of tools related to managing the computer, the devices, or the programs. I list them here in the slide. You can also find them in the book on table 9-1. Operating systems also, as we've discussed, are multi-user operating systems, right? That allow multiple users that are on different computers to access a single system's operating system resources simultaneously. So users can then share a printer, for example, or share internet access, or share files and programs. So when not connected to the network, the client computers can use their own operating system. And then when they connect to the network, the OS on the network is going to assume some of the functions of the OS. So a network administrator is the person, as I mentioned, overseeing the network operations. And the network operations is what uses the server OS to add or remove users, etc. So there's a network administrator as well as an administrator. Okay, so now an administrator, as I just mentioned, is someone who can make changes to the computer that will affect the user's ability to access other resources. I will pick it up there in part 3.